Now this example is pretty similar to the previous example, but we got to look at a little bit more detail here. So we're given the function h of x equals 2x plus 1 if our x values are less than or equal to 2. So that means, in other words, for every x value that's less than or equal to 2, we're going to plug it into this top one. And it's also equal to x squared minus 4 if our x values are greater than 2, so anything bigger than 2. So starting this off, we're asked to do h of negative 2. Going through this, is negative 2 less than or equal to positive 2? It sure is, so we're going to use that top equation. So we're going to do 2 times negative 2 plus 1. Well, 2 times negative 2 is negative 4, plus 1 gives us negative 3. Next, we're asked to plug in x equals 0. So is 0 less than or equal to 2? Yes, it is. So we're going to still plug that one into that first equation as well. So we got 2 times 0 plus 1. 2 times 0 is 0, plus 1 gives us 1. Next one, h of 2. Is that less than or equal to 2? Yes, in fact, it is equal to 2. So we're still using that first one. So we got 2 times 2 plus 1, which gives us a grand total of 5. Bottom one, h of 5. We're asked to plug in x equals 5. Is 5 less than or equal to 2? Nope. Is it greater than 2? Yup. So that means we're going to use this bottom equation here. So we're going to do 5 squared minus 4. Well, 5 squared is 25, minus 4 gives us 21. So for problems like this, make sure you're just plugging it into the correct equation. Now we're going to take this type of information and graph it. So here's the same function. Now we're asked to graph it. So again, h of x equals 2x plus 1 if x is less than or equal to 2, and x squared minus 4 if x is greater than 2. What I'm going to suggest is let's make a quick table. And we're going to have some x values. And then I'm going to make a 3-column here. I'm going to have one function, or the second column is going to be 2x plus 1. So that's going to be kind of our workspace whenever we need to plug it into the first equation. And the second is going to be x squared minus 4, so whenever we need to plug it into the second equation. So let's start off with negative 2, negative 1, 0, 1, 2, and let's go like 3, 4, 5. I'm going to have to extend these lines a little bit. So negative 2, we actually did this one on the previous page, but that's going to go plug into that first equation because it's less than or equal to, and again, this is for x less than or equal to 2, and this is for x is greater than 2. So negative 2 is less than or equal to 2, so we're going to plug it into that first one. So we have 2 times negative 2 plus 1. We already did that one. We ended up with negative 3. Now, our graph here doesn't have any labels, and it doesn't have any negatives. So what I'm going to suggest is I'm actually going to make our axis here and make this a little more, just going to kind of draw a new axis here, and we're going to draw another axis over here. And on our vertical axis, I'm going to have us go up by 3s actually. So this is going to be down here, this will be 0. Oops, sorry, that's a shape. That's 0, then 3, 6, 9, 12, 15, 18, 21. Let me clean this up just a little bit. And then our horizontal axis will just go up by 1. So we need to go all the way down to negative 2. So this will be negative 2. Oops, sorry, that's an eraser. Negative 2, negative 1. We got 0 already. 1, 2, 3, 4, 5. We could keep going. 6, 7. We don't really need to. So negative 2, we ended up getting negative 3, which also, if we're going down by 1s, this down here would be negative 3. Or sorry, going down by 3s. So we've got a point down here at negative 2, negative 3. Plugging in negative 1, we're going to plug it into that first equation again because, again, our x is less than or equal to 2. So we have 2 times that negative 1 plus 1. Well, 2 times negative 1 is negative 2. Plus 1 gives us negative 1. So we're going to be approximately, let's say, about there. Then we're going to plug in 0. We actually did that on the previous page. When we plug in 0, we just get an output of 1. So x equals 0, y equals 1. So we're right about there, a third of the way approximately up. I'm just going to stick with using using red here. Next up, plugging in 2. That's still going to be plugged into the first one. We got 2 times 1 plus 1, which is 2 plus 1 gives us 3. So at 1, we're up at 3. And finally, at 2, we're going to do 2 times 2 plus 1. So 2 times 2 is 4, plus 1 gives us 5. So now we're going to be at the point 2,5, so getting pretty close there. Let me color code this a little bit better. Switch this color a second. It'll come back in a GIF. Okay, there we go. Now, at x equals 2, that's kind of our transition point. At x equals 2, even though this part right here says this is only for greater than or equal to 2, well, technically we could plug in 2.01. We could plug in 2.000001. So even though x equals 2 doesn't work, we're going to get really, really close to x equals 2. So what I'm going to say is let's still plug in x equals 2 and see what happens. So when we get x equals 2, plugging it into the second one, we'd end up with 2 squared minus 4, which would be 4 minus 4, which is 0. Now I'm putting that in a box there because that point doesn't exist, but it is important for us because that's kind of like a boundary. Because we're going to have points really, really close to that dot, but never exactly on that dot. Sorry, I made a little bit of a mess here. Let me rewrite that. So that was 2 squared minus 4. Plugging in 3, that's greater than 2, so then we're going to get 3 squared minus 4. Well, 3 squared is 9, minus 4 is 5. So we're going to have a point at 3, 5, so right about there. Plugging in 4, we got 4 squared, which is 16, minus 4 is 12. That's already going to be kind of like off the graph. So, oh no, scratch that. I'm sorry. I was looking at a different scale. So at 4, we're at 12. So that's right there. Plugging in 5, we're going to have 5 squared, which is 25, minus 4 gives us 21. So at 5, we're all the way up at 21. Now this, we're going to kind of connect these dots. The red dots connect in a nice straight line. The blue dots are going to kind of have that parabola shape where it's going to get gradually steeper as we go up. Now that was not my best graph ever. In fact, that was really bad. I'm just going to try it again. It's going to get gradually steeper as we go up. Connecting that a little bit better. So we got like a linear piece and a quadratic piece. Let's try one more graph like this. So we've got p of x equals 1/2 x squared plus 2 if our x is less than or equal to 2, and 1/2 x plus 3 if x is greater than 2. So I'm still going to create a 3-layered table, a 3-columned table. That's the word I was looking for. We've got some x's. Now we've got some values we're going to plug into 1/2. In fact, let me color code this as red. We'll have 1/2 x squared plus 2, and then the other column is going to be for whenever we need to plug it into 1/2 x plus 3. So I'm going to choose -2, -1, 0, 1, 2, 3, 4, and that should be sufficient. So plugging in -1, that's less than or equal to 2, so we plug it into, or sorry, -2, that's less than or equal to 2, so we plug it into the first equation. So I have 1/2 times -2 squared. Let me write with slightly thinner. So we got 1/2 times -2 squared plus 2. Well, -2 squared is 4. Half of that is 2. Plus 2 gives us 4. Plugging in -1. So I have 1/2 times -1 squared plus 2. -1 squared, doing the order of operations, is +1. Half of that is 1/2. Plus 2 gives us 2.5. Plugging in 0, 1/2 times 0 squared plus 2. Well, that's 1/2 times 0 plus 2 gives us 2. Plugging in 1, we got 1/2 times 1 squared plus 2, which 1 squared is 1 times 1/2 is a half, plus 2 is 2.5. And then 2, we'll do 1/2 times 2 squared. Half of 2 squared is 2, plus 2 again gives us 4. Now, again, that x equals 2, I'm going to call that like kind of our boundary where we transition from one to the other. So even though it's not technically in the second one, it's an important dot for us. So we're still going to plug it into the second one. 1/2 times 2 plus 3. 1/2 of 2 is 1 plus 3 gives us 4. So even though, again, that point doesn't exist, it's going to be helpful for us to use. Plugging in 3, we're going to have 1/2 times 3 plus 3. Half of 3 is 1.5 plus 3 is 4.5. And then we're going to do half of 4 plus 3. Half of 4 is 2 plus 3 is 5. For the graph of this, I'm just going to kind of adjust it again. We need to go all the way down to x equals -2. We could have gone further to the left, -3, etc., but we didn't really need to. For our y-axis, I'm going to go 1, 2, 3, 4, 5. That's about as high as we're going to need to go, but we can add more labels if needed. So for our function here, at x equals -2, we're at a height of y equals 4. So let's put a red dot there. At x equals -1, we're at a height of 2.5, so right about there. At x equals 0, we're at a height of 1. Sorry, I'm looking at the wrong, I was looking at my other screen. We're at a height of 2. At x equals 1, we're at 2.5. At x equals 2, we're back up at 4. And that's where we transition to the other one. Now, the other one ends up also having that same point at 4. Now, it's kind of like an open circle for the blue part, but they kind of share that point, so it is kind of filled in. At x equals 3, we're up at 4.5. At x equals 4, we're up at 5. So for this particular graph, the left side ends up being kind of a parabola. The right side ends up being a linear graph. Let me draw that a little bit better. Like so. So we got two unique pieces of this graph.